The 1940s saw the birth of electronic computing. This was a pivotal moment in human history. The first generation computers, like the ENIAC, were massive machines. They relied on thousands of vacuum tubes. These tubes were glass bulbs that controlled the flow of electricity. The ENIAC used over 17,000 of them. It was a marvel of engineering. The ENIAC could perform complex calculations much faster than any human. This marked a new era in science and technology. However, these first-generation computers had limitations. The vacuum tubes were bulky and unreliable. They generated a lot of heat, requiring elaborate cooling systems. The ENIAC's tubes frequently burned out, causing interruptions in operation. Programming these early computers was also a tedious task, often involving manual rewiring. Despite these challenges, the first generation of computers proved the potential of electronic computing. In 1947, a breakthrough occurred at Bell Laboratories that would revolutionize the world of computing: the invention of the transistor. This tiny device, made from semiconductor materials like germanium and silicon, could control the flow of electricity just like a vacuum tube, but on a much smaller scale. The transistor's impact extended far beyond computers, influencing everything from radios and televisions to medical devices and space exploration. The invention of the transistor is credited to three physicists: John Bardeen, Walter Brattain, and William Shockley. Their groundbreaking work earned them the Nobel Prize in Physics in 1956. The transistor's small size, low power consumption, and reliability made it the ideal replacement for bulky vacuum tubes, ushering in a new era of electronic innovation. Section 4. The transistor's impact on computer design. The arrival of the transistor marked a paradigm shift in computer design. Its small size allowed engineers to create significantly more compact machines. Computers that once occupied entire rooms could now fit comfortably in a single cabinet. This reduction in size also translated to a decrease in power consumption and heat generation. The enhanced reliability of transistors compared to vacuum tubes was another game changer. Computers became more stable and less prone to malfunctions, significantly reducing downtime and maintenance costs. This newfound reliability, coupled with the transistor's inherent efficiency, paved the way for the development of more powerful and sophisticated computing machines. Section 5. A new generation of computers emerges. By the late 1950s, transistors began replacing vacuum tubes in computers, marking the dawn of the second generation of computing. These transistorized machines were smaller, faster, more reliable, and more energy efficient than their predecessors. They were also significantly cheaper to manufacture, making computers accessible to a wider range of businesses and institutions. The introduction of transistors led to a surge in computer development and innovation. New programming languages, such as COBOL and Fortran, were created, making it easier to write and execute complex instructions. The use of magnetic core memory, another key innovation of this era, further enhanced the speed and efficiency of these second-generation machines. The stage was set for an explosion in computing power and its applications.